Packet lesson 4-1, day 2, vectors, found on page 113. Let's dive in. Pre-lesson. I covered a lot of this, not all of it, but I covered a lot of it. So with that being said, actually I think I did cover it all. I just never said linear combination, but we did do one of these in the pre-lesson. But anyways, this says find a unit vector. So remember what we said in the pre-lesson. That means the magnitude of the vector has to equal 1. And this is the formula that's going to get the job done. So the formula says take the vector, which is in form A comma B, which is what they gave us. See that right there? Here's our A, here's our B. And then what we want to do is take each piece, and I'll just say it quite simply, figure out what the magnitude is of this and put it here and put it here. So I'm going to go ahead and draw the drawing. -3, -1. I should have put the -3 there. Let me get rid of that. And so there we go. And so -3 squared plus -1 squared is c squared, which, by the way, that's our hypotenuse, which is the magnitude of the vector. So that's 9 plus 1, which is 10. And take the square root, and I get the square root of 10. Now that's the length of the vector, which is the magnitude. And then I put it down there. All right? And that's it. I found the unit vector, just following the formula. Again, don't worry about getting the square roots out of there. That's not what the goal is. It's just manipulating this formula here. All right, what did I say in the pre-lesson? I said I is the same thing as 1, 0, and I said J is the same thing as 0, 1. And if I distribute, I'd get 5, 0. And then I distribute, I'd get 0, 5, and then I add those together, and I would get 5, 5. So, as I said in the pre-lesson, after you've done 10,000 of these, you would just take the I off and put the 5 in the front, take the J off, put the 5 in the back, rather than wasting your time doing all this, because it happens every time. Now, this problem is asking us to find the magnitude. See 5, 5? Vector starts in the origin, goes like that. How do I know it starts in the origin? Because it's got the little pointy parentheses around it. That means it's in component form. Now we could do this differently. We could say, hey, that's a 45, 45, 90. I'm going to use my 45, 45, 90 rules. And there is my magnitude. But now I got to take this original vector, just like the formula says, and put it over the magnitude. Take your original vector and put it over the magnitude. Now, I suppose they're going to want you to clean this one up because it's a 45, 45, 90. And you'd get 1 over the square root of 2, 1 over the square root of 2 by just canceling out these 5s. And then I don't know if they're going to make you do this or not. I mean, you're going to have to check your answers to see. But then I'd get the square root of 2 over 2, comma, square root of 2 over 2. I got a funny feeling they didn't get the square root out of the denominator for some reason, but we'll stick with our program, okay? And so and it says component form. Well, that's what that is. And this says component form, and that's what that is, okay? All right, so I hope you're getting the gist here. You got to find the hypotenuse, or the length of the spinner, which is also referred to as the magnitude. So because of these looking pointy parentheses, we know our vector starts here, goes to here. Now we know this is -3, we know this is 2. It's just another Pythagorean theorem. So -3 squared plus 2 squared equals c squared. 9 plus 4 is 13. And so I get the square root of 13. I think I did this one in the pre-lesson. So now I take the original vector, and I put the A in the top, B in the top, magnitude in the bottom. And there you have it. You've got your unit vector in component form. All right, that's a warm-up. Like I said, the meat and potatoes is now, okay? Now what I like to do, like I said in the pre-lesson, is I like to write this and kind of ignore this. That V just stands for any vector, which is what this represents, but this actually has the parts. which I think will kickstart your brain a little bit better. All right, well, look at what this says. It has a little picture. It says, find the component form. And I want you to notice, do you see how this has a little pointy thing here and a pointy thing here? I'm going to make it even pointier. Basically, it's saying, hey, slap your stuff in that little formula and it will take care of it for you. Well, this part says find the magnitude of the vector. Well, this is just given to us. So we are just going to put things where they belong. 20 cosine. Wait a minute, what's this? Well, like I said in the pre-lesson, it's how far you spin the spinner to get to that scenario. And then this part of the formula says, put the magnitude there, and then go sine of 30 degrees. Now, that's not wrong, it's just not done, because cosine of 30 degrees actually has value. Now, I mean, what you could do is draw yourself a 30-degree angle, and that's 90 and that's 60. Cosine of 30, that's 1. This is square root of 3. This is 2. So then I get 20 times, what's cosine of 30 degrees right here? Adjacent over hypotenuse, so it's square root of 3 over 2, comma, 20 times, what's sine of 30 degrees? Well, it's opposite over hypotenuse, that's 1/2. Well, 20 divided by 2 is 10, so I'd get 10 square root of 3, and then 20 times 1/2 is 10. Now, somebody in here might just be listening real good, and your mind wandered over here, and you're like, wait a minute, maybe I would have wanted to go like this. 30, 60, 90, if that's 20, that's my hypotenuse, this has to be 10, and then I have to multiply that by the square root of 3 to get that side, and look at this would be my 10 square root of 3, this would be my 10. See, different way of solving it. So you can do it this way or this way, doesn't matter. All right, example 8 has a obtuse angle, which is going to make things a little different. But let's go ahead and dive in. So the formula is, put the magnitude first, which is just 33. They just give it to us. And then cosine of how far we spin, 136. And then magnitude of the vector again, sine of how far we spun the spinner. And this, 136, there is no 30, 60, 90, no 45, 45, 90, so this is where this becomes our good friend. So I'm going to go ahead and turn the calculator on, and I'm going to go cosine of 136. Again, make sure you're in degree mode, not radian mode, times 33, and I get negative 23.7. So this is negative 23.7, comma, now I'm going to do the same thing over here. But I'm going to go sine of 136, and I'm going to multiply that by 33, 22.9. And there it is. All right, but before I go on to the next problem, think about this. This says, from the origin, go left 23.7, and then up 22.9. See how that would take you right to the tip? And it would make sense that this is slightly bigger than these, because the hypotenuse is always bigger. So you always got common sense with you. Okay, now, this is the one I did for you in the pre-lesson. So if you are skipping over the pre-lesson, shame on you, but I'm not doing it again, because we just don't have enough time with these 15-minute opportunities. So we're going to dive into this one. So for the first time, I'm just going to take the shortcut and take the I and the J off right before your very eyes. And yeah, that's what you're going to get every time. So what this is saying is find the magnitude. Now that should be easy, okay? -3, -5, it's asking me to find that length. Now don't take the bait. This is not a 3, 4, 5 family. 4 can't be smaller than this side. The hypotenuse has to be the longest side. So we're going to go a squared plus b squared equals c squared. 9 plus 25 is 34. Take the square root, and I know this is the square root of 34. Now what's the question asking? Find the magnitude. All right, we did it. And the direction angle of the vector. That means they want that, okay? So watch this. I'm going to take this right here, representation of this vector, put a little arrow on it for you, and I'm going to put stuff where it belongs. I'm going to take a little bit of the space up, but so it's going to be from this formula up here, it's going to be the magnitude times cosine of the angle, comma, the magnitude times the sine of the angle. You do not need to do both. You can set this equal to this, or set this equal to this, and you will get home from there. I'm just going to go ahead and start with this front stuff. So I'm just going to go -3 equals the square root of 34 cosine of theta. I'm going to divide by the square root of 34, divide by the square root of 34, and I'm going to get cosine of some angle equals, all right, -3 divided by square root of 34, and that's -0.51. -0.51. So now I got to go second cosine. So this is when I take my calculator and I go second cosine -0.51. That is what I had, right? Enter. See, 120 degrees. And I look at my picture and I think, wait, does this look 120 degrees? No. So what is this problem even telling me? Well, this problem just told you that because you see, if I did go 120 degrees, and I drew a picture 120 degrees, this calculator would calculate cosine being negative over here also. So remember, all students take calc. So your calculator is saying, hey, cosine's negative. These are my two quadrants where cosine can be negative. And I know my answer can't be this 120 that my calculator's spitting out, because that would only take me to here. So what is this 120? Well, the 120, believe it or not, is right there. And so it's 120.6. So theta is 120.66. I'll just keep it at 120.6. So I would need to go 360 minus 120.6, and I get 239.4, and that's the answer that this problem's looking for, 239.4. Okay, if I have a little bit of time, I'll come back to that problem and show the other way, but I don't think I'm going to. All right, let's quickly hammer this one out. So again, it's 3, -5. And the picture would be 1, 2, 3, 1, 2, 3, 4, 5. You see how important it is to draw an image of what's going on? It doesn't need to be perfect, but man, you got to get an idea of what's going on. So, again, this is a squared plus b squared equals c squared. C squared is 25 plus 9, which is 34. So we get the same magnitude, but now we're going to go like this. 3, -5 equals the magnitude, which by the way is the square root of 34, and that's cosine theta, and then the square root of 34 sine theta. And see, I'm going to take this -1, like I said in the pre-lesson. -5 equals the square root of 34 sine theta, because I picked the second one. Divide by the square root of 34, divide by the square root of 34, and I get sine of theta is, and I'm going to do some handy-dandy calculator work, and that's -5 divided by square root of 34, and I get -0.857, -0.857. I got to go second sine, -0.857. Tells me -58. See, this one just flat out gave me the answer, 0.98, so just like that. So, and it makes sense. See, that's my answer because it went down and it built my triangle immediately. All right, I've only got a little bit of time. This says find the component form and the velocity. All right, well, here's the deal. This 525 is the vector right there. If this is 65, this is 25. So I've got everything I need. So my vector would be 525 cosine